mostly solid. Jovian planets. What are we talking about over there? Jovian planets. Mostly solid or what? What do we got for these Jovian planets? Yeah, so another name that people sometimes use for the Jovian planets is gas giants, right? Gas giants is another name that some people will use for the Jovian planets. I don't really like that name, and to explain that, let me draw you guys a quick picture here. Let me kind of move this out of the way. There we go. Let's say that this is Earth. Okay? Let's say that this is Earth. I'll put Earth right here. And let's say over here, I'm going to draw Jupiter. Now, first of all, you guys are definitely right that the Jovian planets are definitely not mostly solid. Okay? They're not mostly solid. Does that mean that the Jovian planets have no solid? Okay, does that mean that the Jovian planets have no solid? Let me put it, yeah, it doesn't mean that, right? It doesn't mean that. They do have solid, okay? The Jovian, every planet's got some solid to it, okay? Now, where would that solid be? Now, check this out. Solid is denser than liquid and gas. Okay, in general, it's not always true, but in general, solid is usually denser than liquid and gas. So if the Jovian planets are mostly made of those other things, where's the solid going to end up? Where's the solid parts of Jupiter and Saturn and Uranus and Neptune going to end up? Towards the center. Just like if you drop a rock into a pool, it will sink to the bottom. The solid materials of the Jovian planets have sunk to the bottom. In this case, because gravity's pointing inward, the bottom is the center. So every one of the Jovian planets has a rocky core, okay? It has a core made out of rock and metal, the exact same type of material that the terrestrial planets are made out of. And we'll get into how we know that a little later, okay? But it turns out that, yeah, if you go deep enough down in the Jovian planets, you're going to hit a center that's kind of similar to a terrestrial planet. But it's under a very different set of conditions, so it's going to have a lot of differences as well. So let's say I drew the rocky core of Jupiter. I'm trying to draw this roughly to scale. Not doing a very good job of it. But, check this out. If this is the rocky core of Jupiter, and this is Earth, who actually has more solid material? Jupiter or Earth? Who has more rocky material, Jupiter or Earth, if I'm drawing these roughly the correct size compared to each other? Jupiter. Jupiter probably has more solid material than the Earth does, okay? So, and other Jovian planets are going to have something similar. They might not be quite bigger than Earth, but give or take, there's at least the same amount of solid. So how come we can say that a planet like Earth is mostly solid, but we can't say that about Jupiter, even though Jupiter's got more solid than us? How come Jupiter can't be called mostly solid if it's got more solid than us? Why not? Why can't we say that this is mostly solid if it's beating us at solids? So, here's the thing. It does have more solid than us, but on top of that solid, yeah, there's so much more gas and liquid than we have that it's got way more of that other stuff than it even has of solids, okay? So even though, it's kind of like, here's a metaphor. Let's say you came into class every single day of class, you came in and you ate a bag of M&Ms, okay? You came in every day you just, right before class, in the last couple minutes before class, you just like, just a bag of M&Ms. Just, after a while, we're gonna be like, hey, M&M's guy. How you doing, M&M's guy? Everybody's gonna start calling you M&M's guy because you just like down that bag of M&Ms every single day, right? But at the same time, what if I came in with like a wheelbarrow? Okay, I've got like a wheelbarrow, and that entire wheelbarrow is just full of Skittles. Just full of Skittles. Just tons and tons and tons of Skittles. And on top of it, I've got 3 bags of M&Ms. I've got a giant pile of Skittles with 3 bags of M&Ms on it. Are you guys going to call me M&M's guy? You're not going to call me M&M's guy, right? What are you going to call me? What are you going to call me if I bring in that pack of candy every single day? What are you going to call me? Am I the M&M's guy? Yeah, I'm Skittles. You're going to start calling me Skittles, right? I'm the guy that brings a wheelbarrow of Skittles every day. I'm Skittles guy. But check it out. Even though you're calling me Skittles guy, I still, even though you keep calling me Skittles, I'm still eating more M&Ms than M&M's guy. Why doesn't anybody notice my M&Ms? It's because of all the Skittles I got, right? And it's the same thing with these planets. Jupiter is Skittles. Earth is M&M guy. He's got basically all solid. And even though Jupiter's got more solid than us, it's got so much other kinds of material that we don't really notice that solid material, okay? So even though it wins its solids, we don't call the Jovian planets mostly solid, okay? So what are they mostly? Okay, we're working our way up to it. Let's draw some oceans. Earth has an ocean. Jupiter has an ocean. Let's add them to this picture. But I'm going to try to draw these oceans the correct size compared to the planet, okay? Now, if I want to draw Earth's ocean on here, okay? If I want to draw Earth's ocean on here, how thick should I make Earth's ocean in this picture if I want to make Earth's ocean the correct size? Is it going to be, you know, something like this? Is it that deep? It's not that deep, right? How thick am I going to have to draw this ocean? Good guesses. Good guesses. So a lot of times people will say, oh, the Earth's surface is 70% water. I don't know the exact percent. 2/3 water, right? Now, we're talking about 2/3 of the surface area of the planet there. We're not talking about the depth, okay? So if I were to draw Earth's ocean in this picture, I would need a much thinner pen. The Earth's ocean would actually be microscopic in this picture. So if I drew it like that thick, that's too thick. That's too thick. Earth's ocean is only a tiny, the depth of the ocean is only a tiny little fraction of the width of the Earth, okay? So Earth's ocean, even though we think of it as deep as a human being, it's not very deep compared to the width of the Earth, okay? Now, on the other hand, let's add Jupiter's ocean on here. Let's check out Jupiter's ocean. Here we go. That's Jupiter's ocean, okay? So this was like the rocky core area. That's Jupiter's ocean. So Jupiter's ocean is ridiculously deep compared to ours. It's thousands and thousands of times deeper than our ocean, okay? In fact, you could take the Earth and drop it in this ocean and it would sink down to the middle, okay? Oh, and of course it freezes with my gross hand up there. There we go. Let's restart. Yeah, if you could potentially stack 3 Earths on top of each other and stand on top of that pile of Earths, and you would still be under the ocean. That's how deep the ocean of Jupiter is made out of. Somebody's asking what it's made out of. Now, I was trying to be very, 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 very careful and not say the word water, because it's not made out of water. Let's see if we can figure out what it's made out of. There's a whole ton of it, right? So it would have to be made out of something that is very, very common. What's the only kind of stuff that's common enough to have an ocean this big made out of it? What's the only kind of stuff? Let's see if we can guess. This should sound similar to a question I asked before, and the answer's the same. So it's not made of gas. It wouldn't be a liquid if it was a gas. But what element is this made out of? What element, probably? It's got to be made out of the most common elements. Hydrogen and helium. Yes, hydrogen and helium. So this ocean right here is made out of hydrogen and helium. Capital H for hydrogen, capital H, lowercase e for helium. So the ocean of Jupiter is made out of the same stuff that the sun is made out of. Except for in the sun, it is a gas, and here it's a liquid. Okay, so it probably looks a bit different than the Earth ocean as well.